So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision Series, we have here these 7 WAEC repeated questions to answer on the topic mass and weight. So guys, this video will be about distinction between mass and weight. So in short, to stay till the end of this video. Let's go ahead and start with the first question here. It says, the following properties of a solid are measured on Earth. I, weight, II, specific heat capacity, III, density. Which of the properties will have a different value if measured in space? We have A, III, B, II and III only, C, II, and D, I. So guys, the only property here that will have a different value if measured in space is I. That's because the force of gravity has an effect on weight, since weight is mass times acceleration due to gravity. So if measured in space where the gravity does not have effect, then the value of the weight will actually change. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 2. It says, in the absence of gravitational force, the weight of a body is A, its density, B, its mass, C, 0, D, its volume. So guys, the answer to this question is option C here, 0. So in the absence of gravitational force, the weight of a body is 0. So that's option C here. So let's go ahead and consider the next question, guys. So the next question here is question number 3. It says, an iron rod is moved from the Earth to the moon. Which of the following remains unchanged? I, mass, II, weight, III, relative density. So guys, we have option A, II only, option B, I only, option C, I and III only, option D, III only. So the answer to this question, guys, is option C, I and III only. So if an iron rod is moved from the Earth to the moon, the parameters here that will remain unchanged are mass and relative density. So guys, the weight is affected by the acceleration due to gravity. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says, the bulb of a simple pendulum has a mass of 0.02 kilogram. Determine the weight of the bulb. So guys, this is a very simple question. The weight is just the mass times the acceleration due to gravity, and the acceleration due to gravity g given to us here is 10 meter per second squared. So if we multiply that by 0.02 kilogram, we'll have 0.2 Newton, and that's option A here. So let's go ahead and consider the next question, guys. So our next question here is question number 5. It says, which of the following statements about the mass and weight of a body is not correct? It's A, weight is a function of the gravitational pull on it. B, weight at the equator and at the poles is the same. C, mass on Earth and on the moon is the same. And D, mass is a scalar quantity. So guys, the answer to this question is option B here, which says its weight at the equator and at the poles are the same. So guys, the weight of a body will vary at the equator and at the poles. So that's because a body will actually weigh slightly more at the poles than at the equator. Perhaps the weight of a body is the force with which the body is attracted to the center of the earth. So a body is meant to weigh more at the poles than at the equator. So that's it for this question. So let's go ahead and consider the next question. So that's question number 6 here. It says, Which of the following statements about mass and weight are correct? We have I. Weight is the force of gravity on a body. II. The mass of a body is the quantity of matter in the body. III. The weight of a body is greatest at the equator. IV. The mass of a body is greatest at the pole. So guys, we have options A, II and IV only, B, I and III only, C, III and IV only, D, I and II only. So guys, the answer to this question is option D, I and II only. So the weight is the force of gravity on a body. The mass of the body is also the quantity of matter in the body. But here, III that says the weight of a body is greatest at the equator is wrong. Actually, the weight of a body is greatest at the poles. So, also, the option that says the mass of a body is greatest at the poles is wrong. The mass of the body is not affected by its position on the earth. So that's it for this question. Option D is the answer to this question. So let's go ahead and consider the next and last question, guys. So that's question number 7 here. It says the mass weight of a body on earth are 8 kg and 80 newtons respectively. Determine the mass and weight on a planet where the pull of gravity is 1/8 that of the Earth. So guys, in order for us to solve this question, the pull of gravity here on the second planet here is 1/8 that of the Earth. That's 1/8 times 10, and that's 10/8. So it means that for a mass of 8 kg, the weight will be 8 times 10/8, and that's 10 newtons. So guys, the mass of 8 kg will actually have a weight of 10 newtons in such a planet, and that's option B here, 8 kg and 10 newtons. So this is where we end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. So this will help you even as you prepare for your WAEC examination for the year. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.